we're going to be able to determine if a graph, table, mapping diagram, list of ordered pair represents a function or a standard, and to display the function a variety of ways. So a function is a special relationship between two numbers. It pairs each input value with exactly one output. Functions can be displayed many different ways, such as tables, lists, graphs, equations. So I don't know if in elementary school you kind of remember this kind of a function machine. You're independent, or your input, your independent variable, you put that in the function machine, exactly one output for each input, and you got a number output. This first video that we are going to take a look at, how does a function work?
How functions work. Let's think of them as a machine that takes an input, performs one or more mathematical operations on the input, and produces an output. So you're taking a few friends out for a buffet lunch that costs $7.50 per person. The rule for this function is that the total cost is equal to $7.50 times the total number of friends going to lunch plus 1. You're going to eat 2, right? Let's turn on the function machine and input a few values to see what lunch might cost. Any value we input into the function machine is transformed by the mathematical operation or the rule of the function. So what if no friends come to lunch? The output is going to be $7.50 because you're still eating. What if 3 friends come to lunch?
Okay, keep shh. Quit.
What if 5 friends come to lunch? Now, let's find the cost of 8 friends coming to lunch. But hold on now, you forgot to include the tip. Let's say that 4 friends are attending the lunch, and let's leave a $6 tip. Now we need to change the rule of our function to $7.50 times n plus 1 plus 6. Let's find out our total cost for lunch. All right, the total cost for lunch is going to be $43.50. Input, mathematical operation, output. That's how functions work.
So, this next one that we are looking at.
Hey guys, this is Mr. Moon.
Hopefully they're not your favorite. Function machine, right? Think about our lunch bag. No. I don't think it's quite that bad, but you know. No F. It's time Wrong. So, when we are thinking about this, okay? So as you take a look at that next page, that next part down in your notes. So, if we are looking at a function, so input and output is what we're looking at. In order for something to be a function, it needs to be unique. So it says, here's a DVD machine. Your input is the code, your output is the DVD that you pick from the bottom. So if we are taking a look at this machine, if you pick B3, what movie are we looking at getting? The Wizard of Oz. Wizard of Oz. It says, well, you always get the same thing every time you put B3 in.
Yes.
Yeah. You always get the same DVD. So this machine behaves like a function. For each input, is there an output? Yes. But there are two Wizards of Oz that come out, right? That doesn't matter. If I put in B2 and if I put in B3, I will get that output. So it is a function, even though I have two things giving me that same output. So what is the domain of our function? We want to make a list of that. Our domain of our function is what? A1, A2, A3, B1, B2, B3, C1, C2, C3. If we are going to make a list, our domain is all of our inputs. So it's listing all those buttons. A1, okay? When we go to list our range is the output. What happens every time we hit one of those? We are going to get the movies starting with Gone with the Breeze, The Godmother, The Star Battles, Wizard of Oz, Finding Nemo, Raiders of the Lost Ark. Obviously, we cannot use real names of movies, correct? We don't copyright laws and all that. So if we are looking, all I did was list all of our movies, right? So again, you could, if you were listing this, list a couple of them, but we're talking about all of the outputs when we look at that, okay? So make sure you start listing some of the names of the movies. I don't care if you list all of them, but I list a couple of them that were up here so that it kind of gives you the idea that we are talking about all of those different movies, okay? So, on the top of the next page, it says, when using mapping diagrams, when you are given a list of ordered pairs, so like in example A and example B, when you're given a list of ordered pairs, a good way to determine if it's a function is to use a mapping diagram. And in a mapping diagram, the first step you're going to do is list all the numbers in your domain. So our domain is simply the X values. So in one column, and then put the range in another column. Domain, it says if the domain is repeated, you will only write it once. Same thing for the range. Step 2, using your list of ordered pairs, you now draw an arrow from each X value, that's in our domain, to the Y value column, which is our range. If each domain number has one arrow, it is a function. If each domain number, that's key, has one arrow, it's a function. If two or more arrows are touching a domain, it is not a function. So, if I look at this first one and I listed my numbers, I would start by listing -2, I put 0, I put 4, and I put 5. In the second one, I put 0.5, I put 2.5, I put 6.5, and I don't write 2.5 twice because I already wrote it down right here. From each of these numbers in the domain, there is only one arrow. This is a function. There is one arrow going from each of these domains. Whereas when I look at B, and I listed my numbers, and they put them in numeric order, but you could have gone with the 6 first, and then the 4, and then there's another 6, and the 5. since there are 2 arrows coming off of that 6, that means if I put in 6, one time I'll get 4, the next time I'm going to get 5. One time, I don't know if the first time I'm going to get it or the second time, but I don't get the same thing. This one is not a function, okay? Because I have 2 arrows coming from the 6, okay? So that is really key to go back to this part when you're trying to decide tonight in your homework, is looking at that. So, that next page down. On the next page down, it says using the vertical line test. The vertical line test is a great thing. It says when given a graph, a good way to determine if a function is to use a vertical line test. If you draw a vertical line anywhere on the coordinate plane and it only passes through one point on the graph, it's a function. So I'm going to give you some graphs, and I'm going to always be asking you on the tests and on your quiz, is it a function? And if it passes this vertical line test and it only passes once, then it is. If the vertical line passes through more than one point on the graph, then the domain value has more than one range. It is not a function. So they gave us all these points, these red dots. -4, 2, -3, 1, 0. They just plotted the points. But because -4 has 2 and -1, it is not a function. Okay? Because when I input -4, I could get 2 outputs. I could get +2 and I could get -1. If I look at this equation, they graphed it. It's a parabola. This is a quadratic equation. We'll get to this towards the end of the year. If I draw a vertical line anywhere on here, and it doesn't matter where that vertical line is, I can take and draw it. As long as I draw a vertical line and it only passes through one point, it is going to be a function. So when I look at that, this first one, second one is a function, the first one is not. Okay? So we want to determine if these are functions. So your job right now is to think, okay, we want to start with domain and range. I'm going to have you do the same thing with this next one. We're going to list those, just as I said in the directions on the last page of your notes. And then the second ones, you're going to be looking at that vertical line test to determine. So if I look at the domain, I have 4.2, I have 5, I have 7, and I don't want to list 4.2 again, right? 4.2 goes to 1.5, and what else does 4.2 go to? 0, right? 5 goes to 2.2, and 7 goes to 4.8. Is this a function? No. And if I asked you why, you would say that 4.2 has 2 outputs. Okay? So usually on the test, I will probably ask you for the reason why. So you just give the no or yes. So then as we look at this next one, if you would again please list yours, and then look at those ones down below and see, does your vertical line test, is it a function or not? You don't have to draw the mapping to see, but in this case, would this be a function? Yes. And our reason, each input has 1 output. Each input has 1 output. So anytime that's not the case, you want to tell me the reason why. So in this next one, should we have a function? If I draw a vertical line anywhere through that. This is kind of like that one in the video, y equals 6. It's a function, right? Y equals 2, that's what this equation is. Everywhere along here you have a horizontal line. It doesn't matter what x you input, you're always going to get 6. That is a function. Okay. If we look at this one, is it a function? No. No. And our reason for it not being a function is at -2, we have -2 with 3, right? And you have an input of -2 with -2. That makes it not a function, because -2 has 2 outputs. The other thing I would take, it does not pass the vertical line test. Doesn't pass vertical line test. If you didn't put down a reason, please put one. Will the last one be a function? Does it pass the vertical line test? No, right? I draw that line, right? The only time where it passes the vertical line test is just at one point. all the rest of these, every place where I draw a vertical line, every single one of those goes through at least 2 points. So if we are looking, is it a function? It is not a function. It does not pass the vertical line test. Okay. Questions on if we are looking at, does it pass the test or not? Is it a function? Okay. So again, it doesn't pass the vertical line test for both of those. So we look at a table of values. So you're going to be asked to look at a graph. You're going to be asked to look at, this is kind of like, if you put on the top, this is kind of like an ordered pair X and Y. This is kind of like 0, 0, 1, 2. So does this table represent a function? For each input, do we have a unique output? Yeah, definitely. If it's a function, what's our rule? So when we look at the rule, we want to be thinking of it this way, okay? When we think about our rule, we could take the input times 2. Now, if we think of our input as x, we might say 2x is equal to our output y. For each value that I take here for my input, x, I take it times 2. So could we graph this? 0, 0, plot your points. At 1, we're at 2. At 2, we are at 4. At 3, we're at 6. 4, we're at 8. And if we are just plotting those points only, we are going to leave our answer like that. So if we graph it, it should be a function. We should be able to see those points individually. Okay? So now you're going to be given some story situations in your homework also. It says, Will runs 6 laps before Megan joins him at the track. They run together at the same pace. Is the relationship between the numbers of laps and each have run a function? So do we think it is going to be a function if we are looking at this? Is each input giving us a unique output? Do you think? Yeah. So if we are looking at this, we know that what Megan has run, right, when we think of writing this, if Megan has run 0, what has Will run? She hasn't ran anything yet. He has 6. Megan runs 1 lap. He runs 7. 2 laps to 8, right? So we could make this up to however many laps we wanted to keep going, right? 3 with 9. Okay. So it says, we want to make 3 displays. So you're going to be asked to do this in your homework also. A table is one display. An equation is the other. What might we use for our equation? So maybe you want to plot it first. 0 is 6. Megan is our x, right? Will is y. So this is Megan's running. This is how much Megan is running. This is how much Will is running. At 0, he's run 6, 7, 8. Would this be, could I draw a line instead of just points, do you think? Meaning, are they only running 1 lap and then stopping and then running 2 laps and stopping? This is kind of a continuous graph, not discrete, okay? So this is a continuous graph. We are going to put this one with a line. So what is our equation going to look like? So a couple ways you can write equations when we are looking at this one. One way is as we are looking at this, we can say y equals x plus 6, right? If you remember last year when you did rate of change, this is our really important, our y-intercept. Anytime when x equals 0, the y value, that's called our y-intercept. It's the point on our graph. We'll be looking at that. And our rate of change, if we are looking at this, each time she ran 1 more lap, so y equals x plus 6. You're going to also have some like this next part down as you look at, where you're going to be looking at these practice. And you're going to be looking at, okay, so I give you this table of values. What could we say? What is our rule? So I just kind of want you to look at this. And it says we're going to use x for input and y for output. So we're trying to write an equation. An equation must have an equal sign, right? Can't just be a relationship or just an expression. So 5 to get 9, 9 to get 13, 14 to get 18. What are we doing to each number? What does it look like as I have that? Adding 4. So if we wanted to look at our equation, we could write y equals x plus 4. For each x value here. Now notice these numbers aren't in order at all. So we're looking at how does the x change the input to get the output. So I want you to look at those next 3 and see if you can. Different one that we are looking at. Henry, what'd you have for that next one? Y equals 6x. How about that last one that we haven't done yet? What'd you get, Evan?
I got y equals x divided by 3.
X divided by 3. Could we write it? So when we look at this, x minus 14, because when we thought of this one, it is adding 35, but that doesn't work every time. So it has to be a pattern that works for every single one of them when we take a look at that. And here, I would take it written this way, or this is the same, right? 6 times x or 6x, yep, I would take that. So it's not wrong if you go with y equals 6 times x. It's just that usually we are not going to put that dot in there because it's understood that if a variable is written right next to a number, that that's being multiplied, okay? Questions on any of those, okay? So your homework looks a lot like this. It is the 2 pages. They're asking you to draw a mapping. So when you start number 1, I need to see your domain, and I need to see your range. And then your answer is it a function? So you still want to do the domain and range like we did in those first ones. And then the question is it a function? Yes, each input has an output, or no. This input had 2 outputs, right? Determine if these are functions. If it's a function, yes, it passes the vertical line test. If it's not, no, it doesn't pass. So, and then these last ones are giving that function rule. Answers are in the back. And I will say that one of the things that I think for some of you